Do I just go?
Yeah.
Okay. All right, so in this process, I'm going to discuss neuromuscular junction. So right here, I'm drawing, please excuse my drawings, okay? I'm not the best artist, but I will draw the best illustrations I can. I'm gonna draw three things. Okay, so in these three things, I'm drawing a neuron, a motor neuron, and a muscle cell, okay? So, we all know that action potentials start in the brain. And these nerve cells or neurons in the brain collect these impulses, okay? And these action potentials are going to start by traveling down the axon. Once the action potential reaches the end of the axon, it is going to send a signal to the motor neuron, which has calcium outside of it. And then we want these gates to open, okay? These little circles right here are vesicles, and they're filled with a specific neurotransmitter called acetylcholine. Now what happens is these calcium ions flow into the motor neuron, causing these vesicles filled with acetylcholine to sink to the bottom. All right. Once these vesicles reach the bottom, this cleft is going to open up. Then you have this little space between the motor neuron and muscle cell called the postsynaptic cleft. Okay. Acetylcholine is then going to flow out of these vesicles, okay, and hang out right here in the postsynaptic cleft area. Okay. Now, acetylcholine is then going to bind to sodium channels. So, okay. Well, as we talked about during cell membranes, we know that sodium requires a integral protein or a channel to allow sodium to flow inside of a cell. So we have 3 sodium in and 2 potassium out. And what happens is this causes depolarization of the cell, or the cell to get less negative or more positive. Once this threshold of -70 is met, an action potential actually occurs. So, sodium gates will close at the maximum contraction of that muscle cell, and is going to repolarize, causing the cells to become more negative, okay? Potassium still flowing outside of that cell membrane. And then once potassium stops diffusing out, it is going to hyperpolarize. Now, let's go back to this remaining ACH. Not all of this acetylcholine is going to be used. The leftover acetylcholine is going to be broken down by a specific enzyme called acetylcholine esterase. It's going to be broken down into choline. Choline is then going to be recycled back into the neuron, and that is how neuromuscular junction works.